Question number 56. Monomer of natural rubber is, I'm just going to draw the structure for this. This is isoprene. And this is the monomer of natural rubber. That's why I'll choose isoprene, that's given in option 2, as my correct answer. Let us take the next question, that's question number 57. Consider the following reaction sequence. Nitrobenzene we have, tin and HCl is added to it. It means reduction is done. A is formed, A is treated with NaNO2 and HCl between 0 to 5 degrees Celsius. It means diazotization of this is done, this A is done to give you B. Now B is treated with HBF4. Just recall what would be formed here. C is formed here and C is further treated with NaNO2 and copper with heating to give you the major product D. You need to just identify the product D. I'll just write here the reaction sequence that's going on. First nitrobenzene we have, and when you treat this nitrobenzene with tin and HCl, it gets converted into A, that is aniline. Now further, this A is treated with NaNO2 and HCl. Diazotization is done. The temperature is maintained between 0 to 5 degrees Celsius. Now this gets changed into diazonium chloride. This is N2Cl. This would be formed here and this becomes B. Now what you did, you just treated this B with HBF4. What will be formed here? The formation of N2BF4 will take place. This becomes your compound C. And now when the C is treated with NaNO2, copper and heat, then it gets changed into the product that is once again nitrobenzene. And if this nitrobenzene is the compound D, this becomes our correct answer also, and it's given in option 2. So just choose option 2 as your correct answer. After this, here's another question. Question number 58. Correct order of melting point of the given compounds is, we have the fluorides of sodium, magnesium and aluminium. If I talk about the melting point, that depends on the lattice enthalpy. It means more the amount of lattice enthalpy, more would be the melting point. It means it is difficult to melt that compound if its lattice enthalpy is high. On the basis of that, aluminium fluoride has the maximum melting point because it has highest lattice enthalpy. Then is the turn for MgF2, and after that sodium fluoride will be there. So correct answer becomes option 2 for your question. Let us take question number 59. Question number 59. The difference between heat of reaction at constant pressure and constant volume for the reaction is, if I talk about heat of reaction at constant pressure and at constant volume, these two are represented by delta H and delta U. And what's the relation between these two? Delta H is equals to delta U plus delta N GRT. This is the formula, that's the relation between delta H and delta U. We are just going to use this formula here. We need to find out the difference between heat of reaction at constant pressure and constant volume. So this difference can be written as delta H minus delta U. You know that? And it is equal to delta N GRT. From where we can get the value of delta Ng? These are representing the number of moles changed during the reaction, and that is equal to the total number of moles of product minus total number of moles of reactant. So we have this given reaction here. Just have a look on that, the reaction that's given here. In this case, the gaseous moles we need to count here. So we can write here this delta Ng is equals to the total number of moles of product in gaseous state, 8, minus what about the reactant? Reactant side total 15 gaseous molecules are there, so this difference will be minus 7 that we have calculated. I'm just going to place the value here. So this H minus delta U, this delta H minus delta U is equal to minus 7 into, what's the value of R? 8.314 joule per Kelvin per mole. And what's the temperature here? That's 27 degrees Celsius. 27 degrees Celsius means 27 plus 273, that is 300 Kelvin. So I'm just writing here 300, and on solving you will find out that this value is approximately 17460 joule, and when we change it into kilojoule it becomes 17.46 kilojoule. So I'll choose option 2 as my correct answer because this is giving me the correct value. After that, question number 60. In which of the following processes entropy decreases? If I talk about the decrease in entropy, this is basically the decrease in randomness of the system. And that you can also represent as system becomes more ordered in this case. Now let's check the options. Boiling of egg. If an egg is boiled, in that case the randomness increases because in that case protein get denatured, a number of chemical changes are taking place. So ultimately in this case delta S increases, not decreases. Further, evaporation of hexane. In case of evaporation of hexane, the liquid was there and it gets evaporated to be converted into vapor. It means entropy is also increasing in this case. Further, crystallization of molten NaCl. You have molten NaCl in liquid state, you have it, and you crystallize it. It is getting changed into the solid state. It means in this case here is a liquid that's getting changed into solid, more ordered form, and that's why you can say delta S decreases in this case. It will be our correct answer. Let's check next also. Sublimation of naphthalene. Solid naphthalene balls you have, and these are sublimed to give you vapors of naphthalene. Definitely in that case also delta S value will increase. So third is the correct answer for this question. So I'll choose option 3.